Out there in the vast expanse of the solar system, orbiting the sun every 271 days, is a space rock known as 2023 DW. It was recently detected when it passed within just 9 million kilometers of Earth. This asteroid is a 50-meter-wide chunk, roughly the size of the one that caused the Tunguska event. NASA estimates that 2023 DW has a 1 in 560 chance of colliding with Earth in 2046, meaning it's likely to miss us entirely. But what if its path were altered, putting it on a direct course for our planet? What kind of destruction would such an impact cause if it struck a city instead of a remote area like Siberia? Could we redirect or push this asteroid away before it reaches us? Discovered in February this year, the 2023 DW asteroid is currently speeding through space at about 86,400 kilometers per hour. Scientists calculate that the odds of it hitting Earth on Valentine's Day 2046 are 1 in 560, though some researchers suggest a 1 in 400 chance. There's even a predicted impact zone marked by red dots on maps, stretching from near the southern tip of India to the eastern coast of the United States. When assessing the danger of near-Earth objects, experts use scales like the Torino scale. Typically, potential threats score 0 or below, indicating little concern. However, NASA gave 2023 DW a score of 1 on a scale of 1 to 10, signaling a slightly higher risk. Over its orbit, 2023 DW is expected to make 10 close passes by Earth, with the first on February 14, 2046. Its nearest approach will be about 0.009614 astronomical units from our planet. As astronomers refine their assessments, the likelihood of a collision dropped to 1 in 1,584. But what if their calculations are wrong? How catastrophic would the impact be? A scientist at NASA's Center for Near-Earth Object Studies compared it to the Tunguska event, where a similar-sized asteroid exploded over Siberia in 1908. The airburst from a 50-meter asteroid could release energy equal to a 12-megaton nuclear bomb, potentially devastating a city if it hit in the wrong place. The Tunguska explosion flattened over 2,000 square kilometers of forest, burning trees and bushes to ash. Witnesses described a fireball as bright as the sun, and the event was recorded by observatories worldwide. Imagine such an explosion over a densely populated area. So, what can we do if a real threat emerges? NASA and the European Space Agency are actively researching ways to deflect hazardous asteroids. Recently, NASA's Double Asteroid Redirection Test, or DART, spacecraft successfully altered an asteroid's orbit by crashing into it. Following this, ESA plans to launch the HERA mission in October 2024 to survey the binary asteroid system Didymos and its moonlet Dimorphos, which was impacted by DART. HERA will use advanced technology, including automated guidance, to map the crater left by DART and measure Dimorphos's mass and composition. It will also deploy 2 small CubeSats to study the asteroid up close. As Europe's leading planetary defense mission, HERA could be crucial for future deflection efforts. By the time 2023 DW makes its closest approach in 2046, space agencies will have a better understanding of how to handle such threats. The success of DART offers hope that we could change the orbit of a dangerous asteroid if needed. However, these plans won't be prioritized unless the odds of impact rise above 1 in 100. But what if we encounter an asteroid that resists our efforts? Recent studies on the Itokawa asteroid suggest some space rocks may be tougher than thought. Scientists believe Itokawa formed over 4.2 billion years ago from the remains of a larger asteroid. These rubble pile asteroids, loose collections of boulders, are surprisingly resilient. Research shows they can survive catastrophic collisions, which poses a challenge for deflection strategies that rely on kinetic impacts, as the porous structure reduces the effectiveness of such methods. However, nuclear blast deflection could be more successful against these porous asteroids. We may need to develop new strategies, as space rocks could hold more surprises. Missions like Hayabusa and OSIRIS-REx are expanding our knowledge of asteroids and their potential dangers. Starting in 2024, the Vera Rubin Observatory will survey the sky, potentially detecting thousands of hazardous asteroids. NASA's NEO Surveyor mission, set to launch in 2028, will further increase our catalog of known asteroids. Scientists are also developing cloud-based data analysis to track asteroids more accurately, helping distinguish between near misses and genuine threats. As we explore space, we're constantly finding new asteroids that could pose a risk. In the coming years, there may be even more dangerous objects waiting to be discovered. Our solar system is home to millions of asteroids and thousands of meteorites weighing about a pound fall to Earth each year, usually unnoticed in forests or oceans. But in 2004, scientists found a particularly dangerous asteroid weighing over 20 million tons. Initial observations gave it a 2.7% chance of hitting Earth in 2029. If an asteroid this large struck, it would cause massive devastation. But what's the real risk, and how can we prevent such impacts? Named Apophis, this asteroid was first spotted on June 19, 2004, by astronomers in Tucson, Arizona. It's about 1,100 feet across, roughly the size of 3.5 football fields. Early calculations suggested a good chance it could hit Earth on April 13, 2029. Since then, telescopes have tracked Apophis as it orbits the Sun, and scientists are now confident it will miss us. Current estimates show it will pass within 19,800 miles of Earth in 2029, close enough to come between us and the Moon. That's within the orbit of some satellites, which sounds alarming. But what if something changes its path? It's well known that asteroid impacts can cause mass extinctions, especially if the asteroid is large enough. The late physicist Stephen Hawking warned that an asteroid collision is the greatest threat to life on Earth. If Apophis hit, it would release energy equivalent to over 1 billion tons of TNT. For comparison, the 2020 Beirut explosion, caused by 2,750 tons of ammonium nitrate, was equal to 1 kiloton of TNT and killed over 200 people. An impact by Apophis over a city would not only kill millions but also have lasting effects on the planet's ecosystem, potentially altering human civilization for centuries. Asteroids played a key role in forming planets in our solar system. Major impacts have shaped Earth's history, from the creation of the Moon to the evolution of life and several mass extinctions. On other planets, asteroid impacts have caused phenomena like Mars' 2 distinct hemispheres and Uranus's unusual spin. While it's rare for an asteroid the size of Apophis to pass so close, smaller ones, about 16 to 33 feet, are more common. These are classified as near-Earth objects, or NEOs, and their orbits are constantly monitored. NASA uses the Earth Impact Monitoring System to track asteroids likely to hit within the next 100 years. NEOs have garnered more attention since 1994, when fragments of comet Shoemaker-Levy 9 slammed into Jupiter, highlighting the danger. As of January 2019, 19,470 NEOs have been discovered, including 107 comets and 19,363 asteroids. These are categorized by their orbits and potential threat to Earth. There are 4 main orbit classifications: Amor-class asteroids, whose orbits don't cross Earth's, posing no threat; Apollo-class asteroids, Earth-crossing asteroids with orbits larger than Earth's. The 2013 Chelyabinsk meteor was an Apollo-class asteroid. Aten-class asteroids, Earth-crossing asteroids with orbits smaller than Earth's, like Apophis. And HERA-class asteroids with orbits entirely inside Earth's, currently posing no threat. Based on these, scientists use scales like the Torino scale to measure impact hazards. For now, Apophis is not expected to hit in 2029, but space is unpredictable. If an asteroid were discovered heading for Earth tomorrow, our current technology offers little defense. Time is crucial. The earlier we detect an object, the better our chances of survival. It's estimated that we'd need over a decade to alter an asteroid's path or mitigate its effects. This has led to the field of asteroid impact avoidance. Agencies worldwide are funding missions to test deflection techniques. Some propose attaching rockets to asteroids to push them off course, while others suggest using nuclear weapons to alter their trajectory or break them apart. These ideas are being tested through missions like DART, a collaboration between NASA and ESA, which aims to crash a spacecraft into an asteroid to change its path. Today, scientists study asteroids' trajectories, sizes, shapes, compositions, and interiors to develop impact avoidance technology. Apophis's close pass in 2029 offers a unique opportunity for observation. Telescopes will be able to study it in detail, potentially revealing surface features just a few feet across. Multiple missions are planned to take advantage of this event. Still, there's a small chance Apophis could pass through a gravitational keyhole, a tiny region that could set it on a collision course for 2036. But the odds are less than 1 in 100,000, giving it a Torino scale rating of 1. So while it's close, you don't need to lose sleep over it. In 2013, scientists launched the Dark Energy Survey, which mapped part of the southern sky until 2019. Using a 570-megapixel camera, it collected data on over 300 million galaxies. Recently, researchers found something unexpected, a comet named C2014 UN-271, or Bernardinelli-Bernstein, about 2.5 billion miles away. It's estimated to be 60 to 125 miles wide, far larger than the asteroid that killed the dinosaurs, which was 6 to 9 miles wide. Its last visit to our solar system was 3 million years ago, likely from the Oort cloud, a distant region thought to hold trillions of comets. Bernardinelli-Bernstein will make its closest approach in 2031, passing 11 astronomical units from Earth, too far to see without telescopes. While it poses no threat, its behavior is hard to predict. Meanwhile, other objects will come much closer. In about a year, the binary asteroid Didymos and its moonlet Dimorphos will pass within 0.07 astronomical units. Didymos is 780 meters wide, and Dimorphos is 160 meters, large enough to cause significant damage. Even small asteroids can be dangerous. The 2013 Chelyabinsk meteor, just 65 feet wide, injured 1,500 people and damaged thousands of buildings. NASA recently conducted a simulation showing that if an asteroid were detected 6 months out, we couldn't stop it. The exercise involved an asteroid 35 million miles away, and scientists couldn't find a way to deflect it in time. Such a mission would take 5 to 10 years to prepare. In the simulation, the asteroid would have hit Eastern Europe, and the only option was evacuation. To test real-world deflection, NASA plans to launch the DART mission between November 2021 and February 2022. DART will crash into Dimorphos at 4 miles per second in late 2022, testing the kinetic impact technique. While Didymos poses no current threat, NASA's database lists over 2,000 potentially hazardous asteroids that could come within 0.05 AU of Earth. Asteroids and comets are often difficult to detect, but sometimes amateur astronomers make significant discoveries. In 2019, Gennady Borisov found a rogue comet, 2I/Borisov, which has no stable orbit and will drift through space until influenced by another object. Studies using NASA's Hubble Space Telescope and the Atacama Large Millimeter Array, or ALMA, revealed it has an unusually high concentration of carbon monoxide, suggesting it formed in a region rich in CO ice, possibly around a red dwarf star or as a fragment of a dwarf planet. 2I/Borisov is the first comet from outside our solar system to enter our region. Its dust grains showed unique polarization, indicating it has rarely been exposed to starlight, making it one of the most pristine comets ever studied. This suggests it holds unaltered information about its formation, potentially billions of years ago. Since its birthplace may resemble our solar system, it could offer insights into other systems like ours. Though it passed the Sun in 2019, other objects may visit in the future, and we can only hope to detect them in time. Thousands of space rocks orbit the inner solar system, many on paths toward Earth. Recently, NASA discovered an asteroid, 2018 VP1, heading our way. Some reports claimed it could hit on November 2, 2020, but should we worry? This asteroid, about the size of a car, was spotted in 2018 by the Zwicky Transient Facility in California. Its path brings it close to Earth, but tracking small dim asteroids is challenging. Factors like the sun's heat or nearby debris can alter their course. The 2013 Chelyabinsk meteor, about 66 feet wide, exploded over Russia, causing a fireball brighter than the sun and injuring many. On August 22, 2020, NASA announced that 2018 VP1 would enter Earth's atmosphere on November 2, 2020, sparking fear. However, it's unlikely to hit, with only a 0.41% chance, and even if it does, it would likely disintegrate before impact. Still, asteroid impacts have shaped Earth's history. Over 65 million years ago, the Chicxulub asteroid, 6 to 9 miles wide, struck Mexico, triggering the extinction of 75% of life, including dinosaurs. Other craters like Barringer in the US and Lake Bosamtwi in Africa attest to past impacts. While the odds of a major impact in our lifetime are low, the asteroid belt between Mars and Jupiter holds millions of space rocks, and over 700 fireballs were recorded between 1988 and 2017. NASA tracks NEOs using multiple telescopes and computer programs to predict their paths. Objects larger than 450 feet that cross Earth's orbit are considered potentially hazardous, PHOs. A 30-foot asteroid could release 100 kilotons of energy, while a 500-foot one could generate 300 megatons, 6 times more than the Tsar Bomba, the largest nuclear weapon ever tested. Even without hitting the ground, asteroids can cause damage, as seen in Chelyabinsk. Nations worldwide participate in SpaceGuard, a mission to catalog near-Earth objects, or NEOs. By 2011, 90% of NEOs larger than half a mile were tracked, and the survey now includes smaller objects. If a large asteroid were detected, our response would depend on timing. If spotted a year out, evacuation might be the only option. But if detected 7 to 8 years in advance, deflection could be possible. Scientists have proposed several deflection methods. One is nuclear detonation, exploding a device near the asteroid to break it up or alter its path. Another is kinetic impact, crashing a spacecraft into the asteroid, as with the DART mission. There's also the gravity tractor, using a spacecraft's gravity to slowly change the asteroid's trajectory. And finally, directed energy, using solar or laser energy to vaporize part of the asteroid, creating thrust. These ideas need testing, and while no threatening asteroids have been found yet, continued vigilance is crucial. Jupiter, the solar system's largest planet, may help protect Earth. Its strong gravity can pull in or deflect asteroids, as seen when comet Shoemaker-Levy 9 crashed into it in 1994. In 2020, an amateur astronomer captured an asteroid hitting Jupiter, creating a visible flash. Some scientists believe Jupiter acts as Earth's shield, reducing the risk of impacts. Jupiter, a gas giant, is mostly hydrogen and helium with no solid surface. Its atmosphere features colorful bands and the Great Red Spot, a storm larger than Earth. NASA's Juno mission has revealed that Jupiter's winds run 1,800 miles deep, and its magnetic field is 20,000 times stronger than Earth's. The planet's core remains a mystery, but pressures there are 100,000 times greater than on Earth. Earth has experienced 5 major extinctions, 4 likely caused by asteroids. The Permian extinction, triggered by a 186-mile-wide asteroid, wiped out 96% of marine species and 73% of land vertebrates. The dinosaur-killing asteroid was just 6.2 miles wide. Today, over 2 million asteroids larger than 328 feet could cause significant damage, and astronomers track 1,360 potentially hazardous objects. The asteroid Apophis, discovered in 2005, will pass within 19,363 miles of Earth in 2029, visible to the naked eye. While it's not expected to hit, its close approach offers a chance for study. Larger asteroids like Eros, 20.5 miles wide, could cause global catastrophe if they struck. If the largest asteroid, Vesta, 326 miles wide, hit Earth, it would be apocalyptic, potentially shattering the planet. For now, we can only hope these space rocks continue to miss us. But with ongoing research and missions like DART, we're better prepared than ever to face the threat from above.